Hi, my name is Dongchun Cho, and I'd like to introduce a paper in IEEE, and the topic is reinforcement learning and belief learning based double action mechanism for edge computing resource allocation. And this is my presentation content. And let me start with introduction. And recently, the IoT has become a disruptive force, reshaping our lives and works, ranging from daily consumption to industrial production. The long distance transmission delay from the IoT devices to the remote cloud service could much degrade the system operating. So in this context, the mobile edge computing called MEC server paradigm is introduced to IoT system. But however, considering the limited computing ability of MEC, how to optimize the resource allocation mechanism is now challenging. So, in this article, we formulate the resource management problem among MEC and IoT devices as a double option game. This is simplified MEC-based IoT system. And this is a system model. We use MM1 queuing model to quantify the emergency level of UE tasks. And T means total delay of a task, and TW means total waiting time, and TS means total service time. And MuJ means the service rate of MEC, and lambda I means task arrival rate of UE. And LQ denotes the average length of the queue. And UE means that user equipment, the bottom part of this system. Now I'll introduce double auction mechanism. Double auction means that it's a process of buying and selling goods with multiple sellers and multiple buyers. And potential buyers submit their bids and potential sellers submit their asks as price to the market institution. And then the market institution chooses some price that clears the market. So this double auction mechanism is into this paper to make some algorithm. In their system, the broker is deployed on cloud computing center since it's ample. Separately, MEC and UEs only need to submit their bidding prices and asking prices to cloud computing center. And there are 4 economic properties. And first is balance of payments, and second is integrity, and third one is economic efficiency, and fourth is personal rationality. And this is double auction mechanism, which is simplified. And we assume competing tasks from UEs are atomic and indivisible, which means the computing task can only be uploaded on one MEC. And the quality of MEC services to UE decided that UE has a different preference for MEC. And due to the transactions being held by the broker, the private information cannot be known to each other. So they made utility function To improve their asking and bidding policy, we need to define the utility function to model participants' profit in one round transaction. And UJ is MEC's utility function, and UI is UE's utility function. And PJ is the total reward in a round of double auction, and cost J consisted of construction cost and maintenance cost. And similarly, utility function of UE is like that, and minus VI LQ denote that there wasn't deal with all sellers, and VILQ is UE's estimate or value to how much profit it can gain by a successful transaction. And in double auction, the broker works to maximize the sum of utility functions of both sellers and buyers. And we can see these auctions as a game. And when we analyze this game, you can see the norm called Nash equilibrium. And the Nash equilibrium is the optimal outcome of the game, where each player in our auction has found its best policy to obtain maximum profit, and no player has an incentive to change its strategy after considering its opponent choice. In their problem, let A star and B star be the optimal bidding strategies and the asking strategies of UEs and MEC. Then the point A star, B star is the Nash equilibrium point if it's satisfied below equations. And next is double auction model based on EWA algorithm mechanism. EWA means experience weighted attraction, and the EWA algorithm combines belief learning and reinforcement learning. The belief learning enables agents to choose their next strategy based on observations of the other agents' choices. And reinforcement learning enables the agent to learn from the experience. For simplicity, we introduce S agents and B agents working as trade agents for sellers and buyers. Then below equation is the updating rule of attraction values. And large A BI and large A SJ means the attraction values of B agent strategy tau and S agent strategy tau. And we use H to denote the significance of history experience of B agent and S agent when choose strategy tau. And this is the algorithm of EWA based double auction. And the important part of the algorithm is repeat all agents give their B and A according to equation 11 and 12. 11 and 12 means the probability of selecting strategy P in the next period after receiving all bidding and asking strategies. The broker can finally decide how to allocate computing resources of all MEC efficiently. Then when converge is equal 1, the loop is ended, and if there aren't, and if it's not converged, then calculate equation 9 and 10 for all agents to update large AAT, means attraction values in all agents until they converge. And this is simulation results. The left side one means that after approximate 800 rounds of double ocean game, policies of all participants converge, and in addition, they can found that the total reward does not reach the maximum value until the convergence of our algorithm, which means that the EWA converges to the optimal solution. And the right side one means when the number of buyers increases, the number of iterations to converge does not increase significantly because their memory and experience help them decide the proper price and finally make this whole mechanism work stable and robustly. And the left one shows that we can obtain a more significant reward by saving money from bidding moderately, because the value increases but strategy does not change, because there is no need for increase the bidding price to assess the service more than 4, so we can save money from bidding moderately. And the right side one means we can discover the tendency that the increase of average cost, sellers gradually raise their average asking price, and in this market sellers are advantageous since their competing resources is limited. Therefore, when their cost enhanced, they slightly increase their asking price. And the data showed that when average capacity becomes higher, sellers will reduce their average asking price, because higher capacity means it can offer edge computing service for more clients and make more profit to make up for its cost. And the last is conclusion and contribution. And they formulated the resource management game where the IoT devices and MEC submit their bids and asking prices to a broker simultaneously. And the optimal solution in this auction was given by a learning algorithm named EWA, which combines the superiority of both RL and belief learning. And their simulations demonstrated the convergence and some characteristics of these EWA algorithms. And the contribution, what I think is constructing MEC-based IoT environment in which the IoT devices can offload their task in MEC for a high-speed data processing and a shorter response time. Thank you for listening.